Chapter 6, Non-Destructive Testing. What is non-destructive testing, or NDT? Non-destructive testing, or NDT, is a testing and analysis technique used by industry to evaluate the properties of a material, component, structure, or system for characteristic differences, or welding defects and discontinuities without causing damage to the original part. NDT, also known as non-destructive examination, non-destructive inspection, and non-destructive evaluation. The first method of non-destructive testing is magnetic particle testing. It is a technique used to detect surface and slightly subsurface flaws in most ferromagnetic materials such as iron, nickel, and cobalt, and some of their alloys, because it does not necessitate the degree of surface preparation required by other non-destructive test methods. This has made it one of the more commonly utilized NDT techniques. Magnetic particle testing is a fairly simple process with two variations, which is wet magnetic particle testing and dry magnetic particle testing. The second one is ultrasonic testing. Ultrasonic non-destructive testing is also known as ultrasonic NDT or simply UT. Is a method of characterizing the thickness or internal structure of a test piece through the use of high-frequency sound waves. The frequencies or pitch used for ultrasonic testing are many times higher than the limit of human hearing. How does it work? High-frequency sound waves are very directional, and they will travel through a medium until they encounter a boundary with another medium, at which point they reflect back to their source. By analyzing these reflections, it is possible to measure the thickness of a test piece or find evidence of cracks or other hidden internal flaws. There are two methods of receiving the ultrasound waveform: reflection and attenuation. What are the advantages of ultrasonic testing? Ultrasonic testing is completely non-destructive. The test piece does not have to be cut, sectioned, or exposed to damaging chemicals. Access to only one side is required. Unlike measurement with mechanical thickness tools like calipers and micrometers, there are no potential health hazards associated with ultrasonic testing, unlike radiography. When a test has been properly set up, results are highly repeatable and reliable. What are the potential limitations of ultrasonic testing? Ultrasonic float detection requires a trained operator who can set up a test with the aid of appropriate reference standards and properly interpret the results. Inspection of some complex geometries may be challenging. Ultrasonic thickness gauges must be calibrated with respect to the material being measured, and applications requiring a wide range of thickness measurement or measurement of acoustically diverse materials may require multiple setups. Ultrasonic thickness gauges are more expensive than mechanical measurement devices. The third one is penetrant testing, or PT. Is dedicated to detecting surface defects invisible to the naked eye. It is based on use of capillary properties of liquids. This method reveals defects by forming an indication patterns on the surface of tested items. These patterns have high optical contrast and width exceeding width of the defect opening. The fourth one is radiographic testing, or RT. It is a method which uses either X-ray or gamma rays to examine the internal structure of manufactured components, identifying any flaws or defects. Radiographic testing is suitable for testing welded joints that can be assessed from both sides, with the exception of double-wall signal image techniques used on some pipe. Although this is a slow and expensive non-destructive testing method, it is a dependable way to detect porosity, inclusions, cracks, and voids in welds interiors. The advantage of this is our volumetric inspection can detect surface and subsurface flaws, permanent records, good quality control method. The limitations are equipment can be bulky and heavy, radiation hazards, testing area needs to be controlled access, equipment relatively time-consuming and expensive, access may be required to both sides of object, may not detect critical flaws, results require interpreting by an experienced person, gamma results interior to X-ray results, gamma less sensitive than X-ray, especially in thin materials, not suitable for certain configuration. Other non-destructive testing methods are acoustic emission testing or AE. This is a passive non-destructive testing technique which relies on detecting the short bursts of ultrasound emitted by active crack under a load. Electromagnetic testing or ET. This testing method uses an electric current or magnetic field which is passed through a conductive part. There are three types of electromagnetic testing, including eddy current testing, alternating current field measurement, and remote field testing. Ground penetrating radar or GPR. This geophysical non-destructive testing method sends radar pulses through the surface of a material or subsurface structure, such as rock, ice, water, or soil. The waves are reflected or refracted when they encounter a buried object or material boundary with different electromagnetic properties. Laser testing methods or LM. Laser testing falls into three categories, including holographic testing, laser profilometry, and laser chirography. Leak testing. Leak testing can be broken down into four different methods: bubble leak testing, pressure change testing, halogen dye testing, and mass spectrometer testing. Magnetic flux leakage. This method uses a powerful magnet to create a magnetic fields which saturate steel structures such as pipelines and storage tanks. A sensor is then used to detect changes in magnetic flux density, which show any reduction in material due to pitting, erosion, or corrosion. Microwave testing. This method is restricted to use on dielectric materials and uses microwave frequencies transmitted and received by a test probe. The test probe detects changes in the electric properties, such as shrinkage, cavities, pores, foreign material, or cracks, and displayed the results as B or C scans. Neutron radiographic testing or NR. Neutron radiography uses a beam of low-energy neutrons to penetrate into a workpiece. While the beam is transparent in metallic materials, most organic materials allow the beam to be seen, allowing the structural internal components to be viewed and examined to detect flaws. Thermal infrared testing or IRT. Infrared testing or thermography uses sensors to determine the wavelength or infrared light emitted from the surface of an object, which can be used to assess its condition. Vibration analysis or VA. The process uses sensors to measure the vibration signatures from rotating machinery in order to assess the condition of the equipment. The types of sensors used include displacement sensors, velocity sensors, and accelerometers. Visual testing. Visual testing, also known as visual inspection, is one of the most common techniques which involves the operator looking at the test piece. This can be aided by the use of optical instruments such as magnifying glasses or computer-assisted systems. This method allows for the detection of corrosional misalignment, damage, cracks, and more. Visual testing is inherent in most other types of non-destructive testing, as they will generally require an operator to look for defects. Eddy current array testing. Eddy current array is a non-destructive testing technology that provides the ability to electronically drive multiple eddy current coils, which are placed side by side in the same probe assembly. Each individual eddy current coil in the probe produces a signal relatively to the phase and amplitude of the structure below it. What are the advantages of using NDT or non-destructive testing? First, there are a number of distinct advantages, the most obvious of which is that the pieces being tested are left undamaged by the process, allowing for an item to be repaired rather than replaced should any problems be found. Second, it is also a very safe testing method for operators, with most techniques being harmless to humans. Although some types of tests such as radiographic testing still need to be conducted under strict conditions. This testing technique can also help prevent injury or fatalities by ensuring structures, components, and machinery is safe. The third one is non-destructive testing is also a very accurate way of inspection since the tests are repeatable and a number of tests can be used together to correlate the results. Fourth, these testing methods are also economical. Unlike destructive testing, NDTs are cost-effective as it can prevent the need to replace an item before malfunction occurs without destroying the piece itself. This testing technique also offers operators peace of mind, knowing that the equipment is functioning as it should, preventing future accidents and determining any measures that can be taken for life extension. Lastly it is also useful for testing of welds and verification of welding procedures to ensure that the welding process has been completed to the correct specification within the bounds of quality control. For example, to make sure that the base metal has reached the correct temperature, cooled at the specific rate, and that compatible materials have been used to prevent welding defects. Thank you.